any natural products that I could use? And this is my answer to that question. I'll just leave it. I'll leave it in this format. There we go. No, let me change it so it's a full screen. All right. Okay, so I'm going to talk about an omega-3 fatty acid that goes by the short name EPA, stands for eicosapentaenoic acid, and we'll talk about some of the evidence to make a person wonder if it's something that's effective in the treatment of schizophrenia. So to get a handle on this, we're going to have to go over, I think to get everybody on the same page, I want to talk about terms related to oils and fatty acids. There's a whole bunch of terms, and I just want to give some brief definitions so that we have some clarity. And we'll talk about some of the rationale for thinking, why would this be potentially helpful, as well as then talk about some specifics of dosing. So on the topic of definitions and terms, fats and oils, we pretty much know what they look like. We can recognize them because they're greasy and oily and fatty. Fats actually have an organic chemistry definition of being solid at room temperature, and oils are liquid at room temperature. And a fat or an oil is a lot like air. Air is a mixture of gases. It's oxygen, nitrogen, carbon dioxide, a little bit helium, a little bit of argon, and so forth. Air is a mixture. Dirt is a mixture of different things. So a fat or an oil is a mix of stuff. And in the fats or oils, there are always a component known as fatty acids. It's a major constituent of fats or oils. And interestingly, if something is solid or liquid at room temperature is very much determined by the kind of fatty acids that are in that mix. Fatty acids are a specific kind of organic molecule. On this picture, they have like little blue dots at the top. Those are the acidic heads. And when I say acid, I mean organic acid. It's a very weak acid. And the golden thing is their tail. Their tail is composed of a bunch of carbon atoms. And they can be long or short, or they can be bent, so straight or kinky. The more bends you have it, the less they're able to pack together, and therefore the more fluid they become when we observe them with our naked eyes. So terms around fatty acids, you'll hear these all the time, and here's what they mean. A saturated fatty acid is a perfectly straight molecule. So on the left, all those are saturated fatty acids, and on the right, those are unsaturated, mixed in. Unsaturated molecules are bent. Polyunsaturated molecules are very bent, so they're the ones that I would call kinky. Essential fatty acids, when something is called essential, it's because we can't make it, therefore we have to get it from our diet. And some of the fatty acids are essential. If we don't get adequate supplies from the diet, our body will fill it in with whatever it can get from hamburgers. Sorry, hamburgers are dietary. So it'll fill in with existing stock, but it won't necessarily be the right molecule. And within the essential fatty acids are families known as omega-9, omega-6, and omega-3. Those are all polyunsaturated. And whether they're called 9, 6, or 3 depends on essentially the shape, like what part of the molecule, in which part of the molecule does the first bend occur. So that's enough for now. Omega-3 fatty acids, we're going to drill down to that because that's where the therapeutic benefit appears to be. Omega-3 fatty acids are themselves a group of chemicals. There are many specific molecules within that group, but the three major ones are ALA, EPA, and DHA. EPA and DHA, you've probably heard about because they're health food store people love to talk about them. They're just different kinds of omega-3 fatty acid. Why is this significant? Because the brain uses these things like a lot. It's estimated that 20% of the non-water weight of nerve terminals is comprised of the omega-3 fatty acid DHA. There are these omega-3 and the omega-6 molecules are the substrates for signaling molecules. The brain can use them kind of like a form of neurotransmitter. And they can mediate signals that are either pro-inflammatory or anti-inflammatory, among many other possible things. In fact, well, to tie into some other topics, cannabis is a popular drug. Cannabis works by turning on receptors in the brain for a substance called anandamide, and anandamide is made as from omega-6 fatty acid precursors. So they're biologically active molecules, or they're the beginning of biologically active molecules. They've been, in multiple studies, they've been shown to have deficiencies amongst many people with schizophrenia. And deficiencies of omega-3 fatty acids in brain are particularly interesting because from animal studies, we're confident that when you change the essential fatty acid composition of a membrane, you change the activity of its neurotransmitter reuptake pumps and its neurotransmitter receptors. So an attractive idea about the fatty acid deficiency hypothesis is that a single deficit can explain multiple facets of illness. So like a single deficit of omega-3 fatty acids actually has been shown in animal studies to account for distortions in dopamine, norepinephrine, and serotonin signaling throughout the brain. So it's saves a lot of stuff. I'm going a bit off topic to show you my own data. The point being that omega-3 fatty acid deficiencies aren't necessarily limited to schizophrenia spectrum disorders. They can be a feature of many illnesses. At my previous position, I was collecting fatty acid levels on everybody. And the graph that you see here shows a big black bar in the percentile box of 1 to 10, which shows that nearly the majority of my psychiatric inpatients had fatty acid levels that were in the lowest 10th percentile of the population. One would predict that a tenth of my patients would have levels at 1/10 the population, but in fact, the majority did. And in particularly, I was interested in the individuals with borderline personality disorder. This graph shows 2 of the omega-3 fatty acids. On the left is EPA, on the right is DHA. You'll notice that on both graphs, the borderline personality population have lower average levels, and it's a particularly marked deficit when we look at DHA on the right. So probably there's something to do with that. I mean, it's so whether it's causal, we don't know, but I think it's interesting that it's a thing that's out there. And also, EPA, when given to people with borderline personality disorder, appears to improve mood, reduce suicidality, and reduce aggression. So there's that. Apologize for the way that this figure turned out. It's very pixelated. But coming back to schizophrenia, this is a graph that shows the relationship on the, my gosh, this is badly pixelated, so apologies. On the y-axis is supposed to read disability score using the WHO criteria for lifetime disability. And on the x-axis is the ratio of fats coming from vegetable or fish versus the ratio of versus the level of fats that come from animal sources. So higher, farther out on the x-axis means that more of the diet is coming from vegetable or fish sources. The dots on the graph represent the WHO estimates of disability for each of 8 countries. United States actually, Denmark was number 1, it's the lowest. United States is about like number 2 or 3. Countries that have the best outcome or the least disability are Nigeria and India. And so, but the countries, it correlates with having a higher percentage of their dietary fat coming from fish or from vegetable sources. And the dietary fat accounted for 90% of the variability in disability outcome, by the way. Again, doesn't prove causation, but it's an interesting relationship. So let's talk about EPA specifically for schizophrenia. This is a very interesting study that came out in 2010 and had a follow-up in 2015. They took 80 prodromal youth. So they were seen as having attenuated psychotic symptoms. Half of the group was given omega-3 fatty acids, half of the group was given placebo. The table shows you at 40 weeks assessment, 27% of the prodromal group had converted to a diagnosis of schizophrenia. Only 5% of the fatty acid treated group had converted to a schizophrenia diagnosis. Interestingly, only 12 weeks of treatment during this prodromal period appeared to have produced lasting protective benefits. If you follow up the patients at 7 years, then 40% of the prodromal individuals on placebo converted to a schizophrenia diagnosis, and just 10% of those who had received 12 weeks of EPA managed to convert. Another study by a different group looked at the dietary habits of prodromal individuals. NC on the table is for non-converting, C, the middle column, is for converting, and HC is healthy controls. I highlighted in yellow the total omega-3 and omega-6 estimated intake from diet, and they found that of the individuals who were prodromal, who ultimately converted to schizophrenia, they had much higher ratio of omega-6 to omega-3 fatty acids. So dietary omega-6 versus omega-3 fatty acid intake appeared to be predictive, or at least a risk factor for conversion to a schizophrenia diagnosis amongst prodromal youth. There are a couple of interesting studies where people have looked at just using EPA as a monotherapy in schizophrenia. So one of these studies was by Pete, and they found that people who got dose information, people who got 2 grams of EPA were able to, in large part, or at least, have decreased need for medication by the end of the trial. People who had EPA had overall as a group lower, many of the individuals were able to be successful off of medication and maintained only on EPA. This brought down the average medication dose in the group of EPA treatment, and despite on average lower antipsychotic dose, the EPA treatment group had lower PAN scores than the placebo group. A different study looked at 80 individuals with first episode psychosis. They were given, again, dose information, EPA at a dose of 2 grams per day, and they found that there were higher levels or higher response rates in the individuals that had received EPA treatment. They found specifically that giving EPA adjunctively to standard antipsychotic medications resulted in a more rapid response time, lower required dose of antipsychotic medication, as well as, interestingly, less extrapyramidal side effects, but that probably is related to needing a lower dose. And interestingly, the group that is more likely to respond to the EPA were the ones that are we regard as the hardest to treat, those that had non-affective psychosis and those that had a longer duration of untreated psychosis. And then this is an interesting case study. This is of a 31-year-old man who had very well validated schizophrenia. His initial treatment with amisulpride led to severe extrapyramidal side effects, so he swore off medication for 4 years thereafter. He remained interested in his well-being and did volunteer for research studies with this group, provided that the research didn't involve medication exposure. So as a result of his engagement with the research group, again, he had a very well-characterized illness, and he had several brain scans during the course of his involvement. It was in fact a brain scan showing the beginning of cerebral atrophy, which led the investigators to offer him, again, 2,000 milligrams of EPA. He accepted that being a natural product, and he basically entered remission. His SAPS and SANS are scores for the positive symptoms and negative symptoms, and they went from symptomatic levels to negligible levels. He was in remission as a result of his EPA treatment. 6 months later, the team did another brain scan and found that the atrophy which had begun was now reversed. And I wrote Dr. Basant Puri an email asking him whatever happened with this case. Dr. Puri wrote back and said this individual enjoyed remission and very high level of function for many years following these reports. He was in fact doing so well that he, like almost everybody does, got the idea that, well, maybe I don't need this anymore. And so he stopped taking the EPA. And then he experienced, unfortunately, a psychotic relapse, which resulted in hospitalization. And after that, he was lost to follow-up from the research group. So I find this case report, many case reports are very difficult to interpret because there's a lot of confounding. In this case report, this is 4 years of continuous illness and remission following a single intervention. And again, after 4 years of continuous remission, relapse following discontinuation of the treatment. So I think it's clear to my reading of this, for this individual with this kind of schizophrenia, EPA was successful as a monotherapy. I don't think that these relationship events can be explained by coincidence or chance. So I highlighted the dose that is used in these studies. It's EPA, not DHA, not ALA, not anything else. EPA, 2 grams per day. 2 grams is 2,000 milligrams. Ways to get it. These are the best ways. This is probably not a complete list because I don't spend my time like looking for OTC products that have this, but there is a pharmaceutical product called Vascepa. It is approved by the FDA for the treatment of hypertriglyceridemia. It will cost about $260 a month with good RX coupon. Insurance isn't going to pay for it because they don't think it works. But the advantage is, for those who can afford it, is that it is pharmaceutically prepared, pure EPA, nothing else. So this would be, in my world, the ideal product for getting EPA. The next best thing, as far as I can see, is a product by Nordic Naturals. I have a slide that says I'm not on the payroll of any of these guys. Nordic Naturals, their product EPA Extra, you need only 4 capsules a day to get the required dose, and that's going to cost you about $65 a month. Notes on the label: just because it says omega-3 or fish oil or whatever, don't pay attention to the front of the box. This is a product which advertises that it has a 1,600 milligram formula. And you might think, that's awesome. 1,600 milligrams, that should be very easy to get 2,000 milligrams. Don't go by the front, go by the back, where it actually gives you the content. So again, omega-3 is a broad category. Within it are many things. If you look at this thing, you will see actually in the middle, EPA, 174 milligrams per 2 tablet serving. So you look at the serving size, you look at the number of milligrams of EPA, you do some division, and in this particular supplement, you would require 23 tablets per day in order to get to about 2,000 milligrams of EPA. This is also going to be relatively low. It's going to be a mixture of a whole bunch of stuff, which is going to give people gassy, awful aftertaste, and it's going to be intolerable for folks to take. In contrast, this is the one I talked about that you can get over the counter for this bottle. Costs about $30, but this bottle lasts 2 weeks at the required dose. And here, 2 soft gels will give you EPA at a dose of 1,060 milligrams. So 4 gels will give you 2,120 milligrams, which is sufficient. So that would be easy to take. And also, this product, to get the EPA, you have to do a lot of refining of the raw products. So you eliminate a lot of the fishy aftertaste stuff from it. So there's that. Again, I'm not on anybody's payroll. My interest is in getting people well, and I'm not here to promote I'm not getting any kickbacks. I did for a time speak for BMS, Otsuka, and for Synovion 5 years ago. I have no ties to anybody anywhere anymore. So just wanted to put that out since it involves product recommendation. So